Hello, future engineers. Welcome to my YouTube channel. To keep me going and refresh so that I will be inspired to do more lecture videos and sample problems, please share my videos to your friends and to your friends' friends. For those who haven't yet subscribed, please do so. I promise to create so many videos beneficial to you as my subscribers and my viewers. So for the beam shown below with constant EI by the conjugate beam method, determine the slopes just to the left and just to the right and the deflection at point C. So we select B and D as our moment centers here. So first let's compute for the reaction at D because this is the portion that is determinate. Then let's transmit the reactions to analyze the reaction at A. So M sub C or moment C equals 0. RD upward times 4 minus 20 times 6 equals 0. So R sub D is equal to 30 kilonewtons as shown. So if this is 30 upward, then the shear at C just to the right should be 10 downward to balance as shown. And by action reaction at the left should also be 10 upward. Then considering ABC, summation moment B equals 0, then we have AY times 6 minus 30 times 10 times 1 because the length is 10 divided by 2, so 5, and this is already 4, so that means the centroid is 1 meter from B. Then minus 10 times 4. So AY is equal to 170 over 3 kilonewtons as shown in the figure. So let's prepare the conjugate beam. So the pin remains pin, the interior roller becomes interior hinge. The interior hinge becomes, it may be pin or roller, but I selected roller, it's the same. As long as the shear just to the left and just to the right are not the same, and the moment left and right equal, then the interior roller becomes interior hinge, the free end becomes fixed. So that's the conjugate beam. Since we select B as our moment center, the moment of the 30 kilonewton load is 30 times 6 times 3. This is second degree. And the value here is 30 times 6 times 3 is 540 over EI. Then moment due to the reaction, 170 over 3 times 6 is equal to 340 over EI. Moment of this uniform load about B, 30 times 4 times 2, 240 second degree, 240 over EI. Then 10 times 4, we have 40 over EI here. Then at D, 10 times 4 is 40 over EI, negative. And 20 times 2 is 40 over EI also, triangle. So that's the figure. Then to solve for the slope just to the left and deflection at C, we need theta B. But to solve for theta B, we consider AB first. So call that theta A, the positive slope. There's only theta A, there's no deflection at A because that's a support. And we have theta B by action reaction. Also at B. There's no deflection at B or moment at B. So for our guide, we have upward force here, downward force here, corresponding to that area. So considering AB, we want theta B, so we sum up moment about A equals 0. And clockwise positive, theta B times 6 plus this moment of area, which is 1/3 of 6 times 540 over EI. This is 6 over 4, 1.5. So its moment arm from A is 6 minus 1.5, so 4.5. Again, this distance is 6 6 over degree plus 2, so 6 over 4 or 1.5, so this is 4.5. Then minus 1 half or 0.5 of 6 times 340 over EI, 2/3 of 6 is 4, so the moment arm is 4. So solving for theta B is equal to negative 130 over EI. Then, having found theta B, let's consider BC just to the left of C. So that's theta C left, the positive assumption of slope, then the deflection counterclockwise, delta C. So to solve for delta C left, we consider BC left, and let's have the guide for areas. Summation forces Y equals 0. So negative 130 over EI plus 0.5 of 4 times 40 over EI, then minus 1/3 of 4 times 240 over EI, the area of the second degree curve, then minus theta C left equals 0. So from here we can solve theta C left. Theta C left is equal to negative 370 over EI. Then summation moment C or MC equals 0, clockwise positive. So negative 130 over EI times 4 for theta B times 4 plus 0.5. Let's copy these terms, then we just include the moment arm. 0.5 of 4 times 40 over EI. 2/3 of 4 is 8/3, the moment arm. Then minus 1/3 of 4 times 240 over EI. If this is 4 over 4, 1, so 3 meters, the moment arm. So again, this distance is 4 meters divided by degree plus 2, 4 over 2 plus 2, so 1. So that means that moment arm is 3 meters. Then minus delta C equals 0. So from here we can solve delta C. Delta C is equal to negative 1266.667 over EI. Then we consider C right and D. So that's theta C right, positive assumption. Same delta C because that's a hint, so the deflected shape will be continuous, so same delta C. Then we have theta D, the force, and theta D. So there's no need to transmit it because we only need theta C right. So we sum up moment about D equals 0 considering CD. MD equals 0, clockwise positive. So theta C right times 4 plus delta C, which is negative 1266.667 over EI. Then minus moment of this area, 0.5 of 4 times 40 over EI. This distance is 4/3, 1/3 of 4. 4/3. Then from here we can solve theta C right. So theta C right is equal to 343.333 over EI. So that's it. We already satisfy the requirements of this problem.